All right. So we have at the top here a chart going over our information. It says one solution. What do you notice about the variable terms for one solution equations? They're not equal. So box those in with your blue pencil, the 3x and the 7x. The variable terms are different. They're not equal. I'm just going to use the word different. Okay? In infinitely many solutions, what do we know about the variable terms? They are equal. So circle 4x and 4x with your green pencil. Okay, so the variable terms are the same or equal. And both sides are also equal. So the constants are also equal. Everything needs to be the same in order for it to be infinite many solutions. Now, what about no solution?
Oh, one is equal and then the other one's not.
Yeah, so the variable terms are the same, but the sides they're not equal. You're right. So the variables end up being the same because they're going to cancel out, but then you're going to have two different constants, and those are not equal. Okay? So let's look at this example. What's my first step going to be? Distributive property. So I'm going to switch just to my pen here. So 2 times 4x, 8x. 2 times 5, 10. 5 times 2x, 10x. 5 times 4, 20. Okay, so now we need to move our variable to one side, right? Are our variables the same?
No.
They're not the same. And we said that if they're different, how many solutions will they have? Do we need to keep going? No, we don't need to keep going. We already know it's one solution because of these variables. Okay, but let's go ahead and solve it, okay, to see what happens at the very end. So let's move our variable terms to one side. So we're going to move 8x. It's smaller, so subtract 8x. 10x minus 8x, 2x. Bring down everything else, so 10 equals 2x plus 20. Now what do I do? Subtract 20. Okay, the 20's cancel. 10 minus 20 is negative 10. Bring down 2x. And what's my final step? Divide by 2. The 2's cancel to 1. 1 times x is x. And what is negative 10 divided by 2? Negative 5. So x equals negative 5. Is that one solution?
Yeah.
Oh, yeah, absolutely. So let's make a note. One solution. We knew that was going to happen from the very beginning, didn't we? Okay, and so now what about filling out the rest of this information? Okay, so what did we do to start? We started to simplify. I'm using my blue pencil because it had one solution. So simplify both sides of the equation. The variable terms they were different, and that's how we knew it was going to be one solution. And the equation can be solved. We knew it could be solved because we saw that the variables were different. Okay, now at the very bottom, I'll zoom out in case you're still writing. Okay, so the equation has how many solutions? So write one solution. The solution means that negative 5 is the only value that will make the equation true. It's the only value that will work. So the negative 5 is the only value that will make the equation true. Okay, so let's look at example 2. example 2, we're still going to have to start with simplifying, right? Okay, so when we simplify this, I'm just going back to my pencil or my pen. We're going to distribute first. 2 times 5x. 2 times 4. Bring down the 11. Bring down the 4x. 3 times 2x. 3 times -1. Good. Okay. So now we did distributive property. Do I need to combine like terms? Yes, I do need to combine some like terms. So on this side, on the left, I have 8 minus 11. What is 8 minus 11? So this is 10x minus 3 equals, and on the other side, I need to combine 4x and 6x, which is how much? So I have 10x minus 3 there. Okay. What do you notice about both sides? If they're all equal, what does that mean? Infinite solutions. So this is true. The statement that we just did is true, and we know it's infinite solutions. So the equation has infinite many solutions. Ooh, I spelled that wrong. Infinite many solutions. Okay, what does that mean? The solution means what? So what numbers can be the answer? It means any number will make it true. So the solution means any value for x will make the equation true. Any value for x will make the equation true. Okay, so back up here, what do we start to do first? We simplified, right? So simplify both sides. Our variable terms were they the same or different? They were the same. And my both sides they were equal or not equal? They were equal, and that's how we knew it was infinitely many solutions. Okay, looking at example 3. All right, so this one, we're still going to start by simplifying, right? So we have -4x. We don't need to do anything with that. Distribute the 3. 3 times 5x and 3 times 6. 3 times 5x? 15x. 3 times 6?
18.
Equals 7 times 2x? 7 times 1. And bring down the -3x. Okay, so we started by to simplify both sides of the equation. Now what do I need to do? Combine like terms. Do I have like terms? Yes. What's -4x plus 15x?
11.
So 11x plus 18. And on this other side, do I have like terms? Yes. What is 14x minus 3x? 11x. Bring down the 7. Okay, what do you notice about the variables? They are the same, but what about the constants? And so is that going to be a true or a false statement? It's not going to work. It's going to be false. So get your red pencil and write false. It's not going to work. Okay, so the equation has how many solutions? No solution. The equation has no solution, and what does that mean? No numbers are going to work. No number for x will work. So, no value for x will make it true. Will make the equation true. So no value for x will make the equation true. Okay, so what do we do to start? We simplified both sides. The variable terms are the same or different? The variables? The variables were the same. So the only time you're going to get no solution or many solutions is if the variables are the same. What determines whether it's no solution or infinite solutions is going to be the constants. And when the constants are the same, it's infinite, but when they're equal, they're infinite. But when they're not equal, it's no solution.